we can use those known series that we just developed for e, sine, and cosine to get Maclaurin series for things that are a little bit more complicated, such as the sine of x squared or e to the negative 3x and so forth. All right, so I'm going to look at number 3. So f of x is equal e to the negative 3x. I want you to go back and see that e to the x, what did we get for e to the x? We got e to the x to be this series. So all I'm going to do, since that was x and that was x, and now I have a negative 3 to the x, I'm just going to do some replacement. So e to the negative 3x is now this series. Instead of x, I have negative 3 to the x. That's all you need to do. What about this one? We developed that the cosine of x was equal to this series. Negative 1 x to the 2n over 2n factorial. So now I want the square root of x. So I can say this cosine of the square root of x, still negative 1, it's still 2n factorial, but in place of x, what am I going to replace it with? The square root of x. And you could leave it like that, but you should know that the square root squared is going to just be x. So I think that's a little bit better way to write it. And that's the cosine of the square root of x. So once you develop the sine of x series, you can just replace x with x squared. And we develop what the natural log of x was equal to in that last example, and you could just replace it with 1 plus x squared. Pretty easy. The next thing you're going to be asked to find is the nth degree Taylor or Maclaurin series for a given function. So they're going to tell you how many terms they want or what degree and what it's going to be centered at. So if it's centered at 0, it's Maclaurin. If it's centered at something other than 0, it's Taylor. All right, so how do we do that? Well, you could repeat that process that we just went through and just write it down. So if n is 5, that means I need to find 5 derivatives. So the first derivative is going to be negative e to the negative x. That's pretty easy. Then I have to evaluate that derivative at c. So my function at 0, of course, is 1. And then the first derivative is going to be negative 1. The second derivative, positive 1, negative 1, positive 1, negative 1. I think you can see that pattern. And so my function, e to the negative x, if I want a 5th degree polynomial, so I just need to say this is going to approximately equal to 1 minus 1 times x plus 1 times x squared over 2 factorial minus 1 times x cubed over 3 factorial plus 1 over 4 factorial minus 1 over 5 factorial. Graph those two functions. Graph f of x is equal to e to the negative x, and then graph this polynomial out to the 5th power, and it's a pretty near match. Okay, looking at the second example, we would go through the same process. So our function evaluated at 0, the cosine of 0 is 1. So I need to find 4 derivatives. Right? Remember about that pi. So the derivative of cosine pi x is going to be negative pi sine of pi x, and that derivative evaluated at 0 is going to be 0. The second derivative is going to be negative pi squared. Doesn't that look fun? But again, we're plugging in 0, so the cosine of 0 is 1, so that's going to be negative pi squared. Then the derivative of the cosine is negative sign, so we're going to have positive pi cubed. So that's going to be 0. And then here, the derivative sign is cosine, so we're going to have pi to the 4th cosine of pi x. And evaluate that's going to be pi to the 4th power. So we can say that the cosine of pi x is approximately equal to, we're going to have 1, then we're going to have 0, so I'm not going to write that down, minus pi squared over 2 factorial times x squared, then 0, then we would have plus pi to the 4th power over 4 factorial x to the 4th power. And again, that would be the approximation or the nth degree polynomial. So this time we don't have c is equal to 0, we have c is equal to 8. So let's rewrite this function as x to the 1/3 power. And now you can see why they gave us 8, because the cube root of 8 is 2. And we don't have to do too many derivatives. So the first derivative, the second derivative, and the third derivative. That's kind of ugly, but it's not so bad. So our first derivative evaluated at 8 would be, let's see, we'd have 1/3 times 1 over the cube root of 8 squared. So that is going to be, let's see, the cube root of 8 is 2 squared is 4, so that's going to be 1/12. Our second derivative is going to be negative 2/9 times 1 over the cube root of 8 to the 5th power. And now I'm reaching for my calculator, and that's going to be negative 1 over 144. So this is going to be 10/27 times 1 over the cube root of 8 to the 8th power. Again, reaching for calculator, and if I punch that in right, that's 5 divided by 3,456. Yuck. Okay, so now since I need this polynomial, so the cube root of x is approximately equal to my function plus my derivative multiplied by x minus c, and what was c? 8, that's to the 1st power. That's the function first derivative. Now my second derivative, but remember that's divided by 2 factorial. Then I have my third derivative over 3 factorial. And then you could simplify that if you wanted to, but that's just so ugly. I'm going to leave it just like that.